In Chapter 8, Section 3, we're looking at another law that allows us to solve the triangle. In this case, the law of cosines is going to be used for case 3 and case 4. In these two cases, you'll notice that the angle must be included between the two sides, or all three sides must be known. So let's review just a second. If we were to look at what we've already talked about, these first two cases here are for the law of sines. And this is where we either had an angle with a side in between it and another angle, or we had a side with two angles. In this case, the side was not included between the two angles. The other one that we had for law of sines is when we have two sides given to us with a non-included angle. So if we found that the given information hit one of these three different types of triangles, then the law of sines was used. In case 3 and case 4, these will be the cases that we can apply what they call the law of cosines to. And you'll notice here just a little bit different. We will sometimes be given a side, then an angle that's included between the two sides. Or we may see a situation where all three sides are known, but no angles are given to us. The law of cosines theorem, you can go through the proof of it. It's not really too terribly bad, to be honest with you. But for time's sake, we're going to look at what the formulas are and go ahead and put them to use. One thing that we need to make sure that we still have information about is, how that triangle is actually set up with the angle is across from the side in relationship, and that goes all the way around the triangle for us. The first law of cosines says something like this. He says, if you're for some reason trying to find the value of c, then c squared is going to equal to the other two legs of the triangle that are squared, so two sides of the triangle. So we'll have a squared plus b squared. And then here minus, we'll have 2 times a times b times then the cosine of c. If you take the square root then of all this, you'll end up with the value of c. Likewise, if you're looking for the value of b, then you'll need to have been given a squared and c squared. And then we could take that product times 2 times the cosine of angle b. So what you're seeing here is that every time that we talk about an angle, like angle C, if we know angle C and we know the two sides that are on either side of angle C, then you can actually calculate c squared, and then to get the value of c, you'll just take the square root of that value. Okay, we'll do the same thing for a squared also. If you're looking for side A and you want to calculate that, then you're going to need information about side B. So b squared, side C, c squared, minus 2bc. And you'll notice here you're taking it times the cosine of A. So the law of cosines deals with the usefulness of cosine, and the two types of triangles that are useful for this type of formula will be the SAS and the SSS. So one thing that in our notes, it already tells us which triangle we're working with, and in a problem, like if you're on a quiz or a test, Of course, that title won't be there. So that's one thing you have to be able to decide, what type of triangle do you actually have your hands on here. And so if we go back and look at this first example, it says that we've been given B is 5, C is 8, and A is 35 degrees. So like I've tried to convince you, sketching the triangle is the most important thing to do. And so an angle of 35 degrees, I could come in here and like eyeball that a little bit. I could call this angle A, go ahead and put that's a 35-degree mark. On either side of this angle would be the other two sides, because remember, when we come up here and we close in this triangle in just a minute, this is where side A is going to be located. Let me go ahead and change colors right here since I don't know anything about that information. So what I do know, though, is I know that B, which was given to me, could definitely be here. This could be B is 5. If that's the case, angle B then has to be across from that. And then if I know that C has to be the other side, then angle C would have to be across from that value. And so here C is 8. Now, one thing I spoke about today was when we're looking for missing angles, and this is only really true about angles, but when you're looking for the missing angles of a triangle, if you can fairly pretty much guarantee us that you're looking for the largest angle of that triangle, then the law of cosines is the theorem that you want to use. If you're looking for the smallest angle of that triangle, then you're going to want to use the law of sines. Now, this is because, like we know that the law of sines is an odd function, or sine function rather is odd, and we also know that the cosine function is even. And so this does give us a little bit of work about, you know, what happens if my angle is in the second quadrant versus the first quadrant. So if you'll stick by those rules, I think you'll be fairly safe. In this problem here, it's asking us to go ahead and solve the triangle. And so the missing pieces that I need to go and find are now written in red there for you: angle C, angle B, and side A. You can kind of see why we can't use the law of sines at this time. Across from the angle, we have an unknown value, so I don't have a pair to set up the proportion. So the law of cosines is really the only way to go. Since this is an SAS, and I was given the information about angle A here, surrounding him or sides B and C, that means my first choice will be to go and find the value for A. So in order to find A, I really have to find A squared first. And so I'm going to use the formula up here that says take B squared plus C squared minus 2BC times the cosine of A. And then as I load in those values, and then we'll put those into our calculator. This will be 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 35 degrees. Once again, make sure your calculator is in degrees. And if we put that in the calculator, we can find the value for A squared. And that's what I'm going to do right now. Put it in my calculator. And it tells me that A squared is equal to, now this value is not exact because our calculator can only store so much. So 23.4678, 3646, and so on. I'm going to leave that value in my calculator right now, and I'm about to take its square root. So then that A is going to equal to 4.844. We're going to go ahead and stick with what we established in law of sines, where we're going to go with sides are going to be 2 decimal places. So this will be 4.84. I'm going to go ahead and add that to my picture here and change the color so I'll know that's something I calculated. 4.84. And now we've got all 3 sides. Now, what we don't have is we don't have all three angles. They did give us that angle A was 35 degrees. And if you look at your triangle right now, that really is the smallest angle. It's just a little bit smaller than angle B, okay? So the largest angle here is actually angle C. So it's best for us to go and use the law of cosines once again, but this time to find an angle like C. So my second step here, I would go and try to find angle C. Now what's neat about all formulas actually, let me write down the one that I'm going to be using here. And the reason I know I'm going to use this version of the formula is because I'm looking for angle C right here. You can actually take the formula and rewrite it. And if you solve for cosine of C, then this is going to end up being C squared minus A squared minus B squared. And this is all divided by -2 AB. And then once we have that value, we can actually take the inverse cosine to find our angle. Okay. So if you go and plug in the values that we know, we can say that C is going to be the inverse cosine then. This way we can do it in one stop shopping. And, oops. And let me put in my values now. My C value was an 8, so he's 8 squared minus 5 squared minus 8 squared. And that's all going to be divided by -2 times 8 times 5. And I think I have one of these guys wrong. Yeah, I do. How about, there's no reason to use 2 8s there, that's for sure. And let's see, if I use this, I want A and B, so let me run back in here. Okay, so the value of C was 8, so that's an 8 squared. The value of A, I need a little bit more room here. The value of A, we can take it as 4.84 and square that. And then we can subtract B, his square, so 5 squared. In the denominator, I actually have -2 times 4.84 times 5. Now if you calculate this, let's see what you get. So we want the inverse cosine first. This is one of those times where if you have the fraction template on your calculator, it'll be very helpful for you. So 8 squared minus 4.84 squared minus 5 squared. And then the denominator, we have a -2 times 4.84 and times 5. Okay. And here ended up with an angle measure of 108. It says 0.77. We're going to go to the nearest decimal place, 1 decimal place, and so we're going to go to 0.8 degrees. Now that we have 2 of our angles, we can actually use the theorem for any triangle. Its sum of its interior angles is 180 degrees. And so if we want to find the missing angle, which is angle B, we'll take 180 degrees and subtract from that the given angle 35 and the given angle that we just found, rather, of 108.8. And if you do that, you'll get 36.2. Now in your homework, if my math lab asks you to round to the nearest degree, then you'll do that. Since we didn't have an actual instruction of what to round to, I'm just going to be consistent through this chapter with angles being 1 decimal approximations and with sides being 2 decimal approximations. Okay. Let me get a clear screen for you here. And now we're off to look at what happens if the given is all 3 sides of the triangle instead. A lot of times people want to jump on this pretty quick because it is not too difficult. However, I still want you to go in here and look at the diagram of a triangle. It doesn't have to be to size by any means, but I think the more practice you get this way, the better off you'll be in the rest of the problems. And so in this case here, if I say I'm going to let angle B represent B down here, which is 8. I'm going to let A be here, and because A is equal to 6 across from it. And then how about angle C there, and let C equal to 5. Okay. Let me go back and redo my colors so that we'll see what all we need to go after. We need to go after all 3 angles. Okay, so if we're looking for all 3 angles, then again, one of the best things to do here is decide which angle ought to be the largest. In this case, it should be angle B, since its side is 8 and it's the largest of all 3 sides. So if we go in there and we go and calculate for angle B, remember our formula tells us that if we're going to use angle B, then we need to know B squared. We'll have to use knowledge about A squared, C squared, and we need to know something about angle B. Well, if I don't know angle B, all I have to do is just plug in my numbers and isolate B, or I can come back and rewrite my formula as the cosine of B is equal to B squared minus A squared minus C squared, all over negative 2AC. And so then our angle B will end up being the inverse cosine of this fraction. So if we go and plug in what we know, then we have an 8 that's squared minus A, which is a 6 squared, minus a C, which is 5 squared. And now divide all that by negative 2 times 6 times 5. We'll put that in your calculator. Again, I would use that fraction template if you have it. If you don't, just be very careful when you go to load this in. You can make a lot of errors just by loading in the wrong thing into your calculator. And let's see what we end up with. How about a 92.9 degree angle if we round it to 1 decimal place? So 92.9 degrees. Now it's down to angle B and angle C. So out of angle B and angle C, angle A and angle C, which one of those would be the smallest of those 2? And it looks like angle C is just going to be a little bit smaller because it has the smaller side across from it. So let's go and look for information about angle C. Since angle C is the smallest angle for this triangle, we're going to go ahead and use the law of sines. And so I know that I'm going to be interested in C. So the sine of C is across from side C, which is 5. I just calculated the angle for B. So how about the sine of 92.9 divided by then 8. And if you go in there and now solve for C, first thing we could do is we could say that sine C is equal to 5 times the sine of 92.9, and that's all divided by 8. And then C will equal to the inverse of sine of this fraction. We're already expecting this to be the smallest angle of what was left. And so we know our answer has to be less than 92.9 for several reasons. But what we've been looking at lately is how that fraction looks. So let me get in here 5 sine of 92.9 and then divided by 8. And it tells us that C is going to be to 1 decimal place here, 38.6 degrees. Well, we pretty much know the routine. If you've got 2 angles of a triangle, how do you find the third? So angle A is going to end up being 180 degrees minus these other 2 angles that we just found. And so if we'll check that out. We get 48.5. Well, looking back at the picture, it kind of makes a lot of sense that C, being a 38.6 degree angle, he's across from side that's the smallest. B was across from the side that was the largest, which was 8, so he's 92.9 degrees. And then the one that's kind of in the middle of those 2 extremes, that would have been angle A, because he has a side value of 6. So we can put these actually in application form too. And when we go to the application of what we're doing now, it comes in lots of different types of problems. This one here is about an airplane. And an airplane is flying, it says due north. And so one of the things we got to remember is that, you know, we know due north means this. As we read through here, one of the things it talks about is that it flies from Fort Myers to Sarasota, and that's a due north pathway. And then they talk about how far it went. And then after it reached the 150-mile line, then he turned through an angle of 50 degrees. So to turn 50 degrees through an angle, what that means is that when you're on a north bearing and you want to turn 50 degrees, then you're going to turn to the right 50 degrees. And that's what that bearing looks like. Okay. So when you turn an angle, and this angle does not have to be an acute angle like it did when we talked about headings, but in bearings, you can go all the way around from the north to get into different quadrants. Here it just said to turn 50 degrees, and so we would have a heading out that way. So let's look at our picture then. I'm going to use the letter F for Fort Myers. So if I use an F for Fort Myers, that means he's going to start here. He's going to travel 150 degrees, 150 miles to Sarasota. And at Sarasota, I'm going to put an S. Now, what I know is going to happen here is he's about to make this turn. So let me show you one thing that you can do on yours. I like using different colors, it helps. But right here, I can superimpose the compass again. There's north. And what they told me is that I'm going to now, from Sarasota, I'm going to take a 50-degree turn. So we're going to turn through 50 degrees. Now, when I turn through 50 degrees, what that means is once I leave Sarasota, my plane is going this way. So it changes my direction that I'm flying. Let's not forget right here that they did tell us that this was a 50-degree angle. That will be necessary in just a few minutes. Now, when I reach Orlando, because that is the next stop for us right here, I'll just put a big O for Orlando. You can kind of see that he tells us nothing more other than we're going to travel 100 miles. And now it's up to us to form the triangle. Well, the only way the triangle is going to form, obviously, is from Fort Myers up to Orlando. That's where it's going to form the other side of the triangle. So while we're looking at this triangle, before they even ask us things about what we're supposed to find, this is just drawing out what's happening in the problem. In our case, you can kind of sort of see we've got two sides here. We actually have the side of 150 miles. We also have another side of 100 miles. We actually do know the information about the angle between those two. If you look at the picture, the north-south line is actually 180 degrees from north to south. And so here we had to actually turn through 50 degrees. And so if you do the arithmetic from where we ended up with our new route to where we started, this yellow piece that I'm drawing in right here, that would end up looking like a half circle, which is 180 degrees then. So what I know then in that yellow piece, let me change colors so it'll show up better, is that angle that's between sides of 150 and 100 is actually going to be 180 minus the 50-degree turn that we made. That's 130 degrees. So the yellow angle right here is 130 degrees. Let's go see what they want us to do with this picture then. They'd like for us to figure out how far it is directly from Fort Myers to Orlando. So let me get a rough sketch of what we had before. You can look back at your paper if you'd like to. We started here at Fort Myers. We went to Sarasota. We turned in 50 degrees to head out to Orlando. And I think I used a green color here. That's what we need to find. The other information that we were already given, we were given that this was 150 miles, 100 miles, and you're supposed to find out what this piece is right there. I'll just call him X. We also calculated what our angle was between those two, and this angle right here is 130 degrees. So if you look at this, it looks like we have an SAS. So if we have an SAS triangle, then that implies that we're going to be using the law of cosines. And this is where the alphabet kind of goes away. We've been working with formulas that said ABC. Now I have a triangle that's like FSO. So you really just have to understand the pattern of the formula. What I know is that my unknown is X, and he's across from that 130 degree angle. So in order for me to find X, I can say X squared. I can use the two sides that are on either side of my angle. I can subtract then 2 times each one of those sides, and then times the cosine of 130 degrees. Now, we really don't care that much about what X squared is, so we really just want to know what X is. So my suggestion is in your calculator, I would go ahead and just load up what the square root of all of this is and go straight for your answer. Okay. I don't expect to see this done by hand. So if we go to our calculator, pick up the square root function, and now let's go in there and see what we have. 150 squared plus 100 squared minus 2 times 150 times 100, and then the cosine of 130 degrees. And you'll get a value, it looks like, if we go to 2 decimal places, 227.56. Our unit back there was in miles. And so that's how far it is from Fort Myers to Orlando straight. It should be larger because the 130-degree angle, obviously, at Sarasota is definitely going to be the largest. So I knew my answer had to be bigger than 150 for sure. Now, this last part of this problem says, well, what's your bearing? And when we talk about a bearing, okay, this is your measure from due north. So if we're here at Fort Myers and we're trying to get to Orlando and we want to go straight there, then what we need to figure out is, well, what is going to be, right, our bearing from north? That's what we want to figure out. What is our bearing from the north? So let's go back up to our picture again. Remember, from Fort Myers to Sarasota, we were straight up to the north. We turned and went to Orlando. We ended up with 150 degrees here. We just calculated that this is 227.56 miles. We were also given that this is 150 miles. And this is 100 miles. The reason why we kind of got lucky on this one is because since we went straight from Fort Myers straight north to Sarasota, the actual bearing that we're looking for here is right here. Because remember, this would have extended up to, this is the north. Our plane that we're interested in right now is taking this pathway right here. So that's why we're interested in that small little angle right there. So the question is going to be then, how do we find it? And if you go back and just use the general knowledge of the triangle FSO, which one of those angles looks to be the smallest? And if you look at that, it looks like F is going to be the smallest angle. F is across from 100. O was across from 150. So I think that if you and I were to set it up so that we can use some information here, we could use the law of sines, because this is definitely going to be the smallest angle, and this is the one I'm after. So if I look at the sine of F is to 100, as the sine of 130 is to the value 227.56. We can go in there and solve for F. Here we would have 100 sine 130 degrees divided by 227.56. And now if we go in there and take the inverse sine, so if we have the inverse sine, and we have 100 sine of 130 divided by 227.56. We will find out that F is a 19.7. If we go to 1 decimal place, 19.7 degrees. This is the bearing. So we would say that the bearing that the pilot should use would be 19.7 degrees. The minute we say the word bearing, they know it's from the north. Okay. Hopefully that'll help you a little bit. Please work on trying to diagram these triangles. Once you get that part, the rest of it's pretty plug and chug, and hopefully this will help you.